you very much, Jared. And Jared, if you have something that's, if I've messed up or something, feel free to put something in the chat. Jared's going to help me with that. And also, thanks to everybody for coming. I'm really delighted to see so many people, but also I appreciate there are a number of people from the project who are on online who can help me out with this. So I've got some backup if we need it. So I'm going to share my screen and start my slides. There we go. I hope, Jared, can people see the slides now?
Yes, yeah, looks good, George.
Okay, good, thank you. So as Jared mentioned, the SDTL is a product of the C2 metadata project. I won't say a whole lot about it, but about the project, but you're going to see a number of things that were created on the project. And C2 metadata was funded by the National Science Foundation. So SDTL is a language for describing data transformations. And it was created by the C2 metadata project because the goal of that project was to automate the capture of provenance metadata. In particular, provenance metadata coming from statistical analysis software, such as SPSS, Stata, and so on, that are very heavily used in the social sciences. And so SDTL is a description of data transformations. The primary goal of our project was to use SDTL as documentation for data files. But SDTL has gone beyond that. We do believe that SDTL could be translated into another language to be executable. We'll see a little bit more of that later. But we haven't created any software for that yet. That's still down the line. So SDTL was actually created with DDI in mind. And we believe it fills a gap in the DDI product suite. For many years, people who've been involved with DDI longer than I have say that the people in the Alliance recognize the need to have a machine actionable way to describe data provenance. And SDTL fills that need. From the beginning, I think all versions of DDI have had ways to describe how files and variables were produced. But what's been used in those fields up to now have been text strings, which are, first of all, idiosyncratic, and secondly, not machine actionable. What SDTL does is it makes these file and variable histories easy for machines to act upon. And that adds new capabilities to things that are based on DDI, such as data catalogs and codebooks. So the S stands, so SDTL is a language for describing data transformations, as I said. What does that mean? Well, SDTL was really created in the framework of standard statistical software. And so what we're describing is a rectangular data array, as you would use in SPSS or Stata. In the more recent languages like R and Python, they have more than one kind of data array. And in those languages, what we're describing is what they call a data frame. And a data frame consists of rows, which are observations. They could be people, they could be years in a time series or something else, and columns, which are variables. That is to say, attributes measured on the individual in those in the rows, and where each cell in that matrix is a value. Now, the structured part of SDTL comes from the fact that SDTL is implemented in as a JSON schema, which is to say a format that's easy for computers to read, and it can be serialized into other machine actionable formats. So why write a new language for this? Why didn't we just take R or SPSS or one of the others? The first reason is that when I looked at the logs at ICPSR about what languages people downloaded data in, it turned out there was no one winner. Among the social sciences, some people use SPSS, some people use SAS, some people use R, and so on. And so you can't really serve the whole community if you just choose one of those very well, because those languages are very different. And if we chose Python, as you see below here, it would look very strange to someone who is used to Stata. The second reason is the structured part. Software can read and process SDTL files directly. Other languages need to be parsed. So here's an example of two Stata commands that look like they're the same. They have all the same words and symbols in them. But what happens is if you actually run them, the results are totally different. And that's because in Stata, the context matters. It depends, it matters whether the if comes before or after the replace. SDTL, because it uses these structured formats, which you'll see, which consist of tags and nested structures, the structure removes a lot of ambiguity, which is very useful for machine. So Stata and SPSS and other languages have their own internal parsers, but SDTL skips that step. So let me start with an example of how SDTL is used. Suppose you downloaded some data from a public place like ICPSR or IPAMS or the UK Data Archive or one of the SESDA members, and you wrote an article, and then using that data, and the journal wants you to send them your data, and they also want you to send an annotated description of the data. So what have you got? You've got an SPSS file that you created, and you've got a DDI XML file from the data repository. So how do you make a code book that describes the way that you change the data? So you could do this yourself in an Excel spreadsheet or a Word thing, but we provide a faster way to do it. So here's an example of an SPSS command script, a very simple one, for example. And you can go to our website where you'll find this online form. And this is a form for something we call a data transformation recorder. It's going to record all of the changes to your data. So what do you put in there? Well, there are three things it asks you for. First of all, the command, you have to upload the command script. Secondly, you have to say what the name of the input data file is inside the command script. And thirdly, you have to upload the DDI XML file from the data that you started with. And then you come over here and you click on Go. And actually, for simple things, in seconds, you get a new screen that looks like this. And this screen has 3 download buttons. The first download button is for an SDTL script. The second download button is for an updated DDI file. So this is now a DDI file that matches the data that you used in your analysis and that you've posted with the journal. And thirdly, a codebook, which is in HTML. So if you download and open the codebook, it looks something like this. This is a simplified prototype that's for demonstration, but it has some interesting features. These light blue things here represent, first of all, a description of the data before your script was run. Secondly, a description of the data after your script was run, and then some temporary states of variables, which I won't talk about right now. So if you click down here, you'll find descriptions of the variables. And these descriptions have a number of things in them. So this is a variable name. And first of all, you see here that we've got here the SPSS commands that you used. Secondly, we now have a translation of that SPSS command into natural language. So it's, no matter which language you use, it'll be something like this. It's designed to be something that anybody can read. And thirdly, there are hyperlinks that can take you from the result variable to the variables that it was based on. And then over here, now, we haven't seen the SDTL, but if you click on this thing here, the SDTL appears. And this is what SDTL looks like. And I'll go through this more. So this all goes very quickly. Let me tell you what actually happened. So we started with a command script, and that gets read by a piece of software that we call a parser, because it parses the original language. The parser also takes input from the original DDI file, which looks like this. And but what the parser is looking for from the original DDI file is just a list of the variable names in the original file. The parser also uses an SDTL component that we call a function library, which we'll talk about later. The parser takes this command script and it produces a new script that's in the SDTL language. That script now goes to another piece of software called an updater, which also reads the original DDI and uses a piece of software called a pseudocode translator to translate the SDTL into natural language. And the updater produces a new DDI file that describes the data after the transformations and includes the SDTL and the natural language description of the changes. That DDI file can be used in a number of ways. It can be used in an online data catalog, like ICPSR or Stata, or you can send it to the codebook formatter and create an HTML codebook, which is what we were just looking at. So we began with two inputs, a command script and a DDI file before the script was run. And what we got out were three outputs: this SDTL version of the command script, a post-transformation version of the DDI, and an HTML codebook. These steps, these blue steps, are actually software created by the C2 metadata project, and at the end I'll tell you where you can find them. And all of these steps were orchestrated by the online data transformation recorder webpage. So you didn't have to pick, run each of these separately. They were all run as a series, depending upon which language you used and so on. These two things, the function library and the pseudocode library, are parts of the SDTL standard, which we'll talk about a little in a few minutes. Okay, so what does SDTL look like? SDTL consists of types, and each type has a property, and these properties are all named in the JSON file, which I'm going to show you in a second. So let's take the example of a compute statement where we're taking age measured in months and dividing it by 12 to get age measured in years. Now, one thing that I have to warn you about is that SDTL does arithmetic by using functions. So from the point of view of SDTL, division doesn't look like age months /12. Division looks like use the division function with age months and 12 in that order. So here's what that command looks like in SDTL. And I'm going to break this down and tell you what we have here. So first of all, notice that the original SPSS command is inside here. We carry that forward so you can know what for reference later on. This is the definition of the schema for a compute command in SDTL, and it has some background information like which we call source information, but basically it has an output variable, which we call variable, which is set equal to an expression. So here you see the way that a variable is referred to in SDTL. We call this a variable symbol expression, but it's just the name of the variable. And here you see that to get that the expression was the result of a function call. And here we have the name of the function. And then that function has arguments. And we see here, there's the variable that is the numerator in the division. And here we have the denominator, which is a number. And these have argument names for the parameters in the function. So this is what SDTL looks like. Obviously, it's a lot more verbose than the original command, but by having these tags, it makes it easy for a computer to read it. SDTL is a common syntax that can be used with various languages. And here I've got just an example of a RECODE command in 3 different languages and what we call a collapse, or sometimes called an aggregate command. The point here is that we can take commands like this collapse command, which SPSS calls aggregate, Stata calls collapse, R calls summarize, and we can map them all into an SDTL schema. What happens then is the SDTL is inserted into DDI Codebook. So this is part of a DDI 2.5 description of a variable. And the variable is actually right here, reg2, and it has an ID and it's found in file F2. This is the SDTL, the original SDTL, which is described here as using SDTL POJO syntax. Here's the original SPSS code. This DDI tag points to a variable that was used in the creation of the new variable. And here we have the natural language or pseudocode version of the command. So DDI 2.5 captured all of the things we saw in that codebook. That's how the codebook works. DDI lifecycle does this a little differently, but it also can capture all of the things. So this is a small snippet from DDI lifecycle, and you can see here, this is the full SDTL, but here is the natural language translation of the SDTL. So let me talk about some other uses for SDTL. So one of the things we hope that SDTL will be used for is the data production process. And what we envision is a data production process for like surveys and things like that, where the whole process is based on DEI from beginning to end. And we think SDTL has an important a role to play in that, because one of the problems in moving to a full DDI-based production system is that if you change the data by running a script, SPSS or SAS, the DDI that you started with is not the same as what you get next. And editing DDI is not fun for anybody. What we've done with SDTL and with the C2 metadata tools is that we've made it possible for you to automate the process of updating the DDI. So, you know, you run a script on it, you change the variables, fine. Then you just update the DDI, and everything at every stage of the workflow can be DDI based. That has other advantages, which I'm sure some of you know about, which we can talk about later. A second thing that you can do with DDI is you can actually audit the scripts that you use to create, to change the data, because SDTL produces variable histories. As you saw in the codebook that I showed you, you can assemble all of the SDTL that affects this variable, and you can actually go backwards to the previous variable. So it's possible to pull together a full history of a variable by assembling the various SDTL parts. Another thing, usage of SDTL that emerged recently, especially from our friends who are on the DDI cross-domain integration project, is using SDTL to describe relationships between different measures. And this is a slide that Larry Hoyle provided me with. And so if you've got you know, a workflow or you want to, where you're describing, you start out with measures, a measure of distance in kilometers and a measure of time in seconds, and you want to end up with miles per hour. Well, you can use a little snippet of SDTL to describe how you go from kilometers to miles, and how you go from seconds to hours, and then how you go from miles and hours into miles per hour. Because SDTL can, as we saw in the compute command, can do that. CDI, however, is especially about changing data structures, going from wide to long and other things. And SDTL can be used to describe those processes too. So suppose we start with a wide data file with one row per person, where each column is a variable. And then we change it to a data cube by aggregating on state, gender, and age group, and producing an aggregated variable account. Well, SDTL can describe this process. This is not in the full JSON format, but this is a collapse command that describes going from this wide format to this aggregate format. And also in the data cube form, data cubes consist of dimensions and measures, and SDTL has a way of tagging which variables from here become the dimensions and which ones become the measures. Finally, one of the things that we believe can be done with SDTL is that you could translate between two different statistical languages. So you could start with SAS and wind up with R or Python or something else. Now, right now, SDTL, and especially the software, is not complete enough to do that, to get you to the final script. But even if we help you with 80% of it, that's a tremendous advantage, and can save a lot of work if you have a lot of code that you have to move to a new system. So now, what does SDTL consist of? And here, what I'm going to talk to you about is the SDTL standard that the DDI Alliance is proposing to adopt. This is what, those of you who will be voting, this is what you'll be voting on. And you'll be voting on three different things, which I'll go into more detail on. First of all, the SDTL language. Secondly, the function library. And thirdly, the pseudocode library schema. Now, the DDI Alliance will not be responsible for any of the software that has been created by the C2 metadata project. That software is all open source and anyone can use it. And the DDI Alliance will not be managing software updates. It will only be managing the standard. So the SDTL consists of elements, and they fall into various categories. Basically, there are commands, and there are elements that are used in expressions. And I'm going to go through them pretty quickly. So this is probably the thing that you're most interested in, which is the commands. What can they do? So SDTL commands can create variables, change the values of variables, compute, recode. SDTL also has commands for managing metadata, like value labels and data types and print formats. There are two commands for reading and writing data, load and save. There are commands about changing the structure of a data frame. By this, I mean changing the number of rows, changing the number of columns, or completely restructuring, like we saw in the aggregation example that I gave you a minute ago. And finally, SDTL does have commands for managing the flow of operations in a script, and like, do loops and if statements. The analysis command, those were commands that actually change data or metadata. These commands just provide information. We have a variety of them. SDTL does not do analysis commands, which is something I'll come to later. SDTL was created to describe data transformations to data. If it's something that you're going to make into a table and put into your article, that's sort of not in scope for us. These are the elements that are used to describe constructs and expressions. So we have things here for strings, for numeric constants. And we also have ranges of various kinds. And then within this group are things that describe variables. And we have a number of ways of pointing to variables. So this is the simplest way, which is just a variable name. But as you know, in most statistical languages, you can do certain things on groups of variables, which can be described with lists or with range expressions like variable 1 to variable 15. And SDTL can do that. And SDTL also has a way of referring to variables that are in arrays, which is needed in certain kinds of programs. Then there are a number of things that are sort of housekeeping things within SDTL that are used when a command or a property is very complicated. So all in all, SDTL has 71 of these language elements, which by my reckoning is not very large. And there are a total of 28 transformation commands in total. So it's not a very large language. So the function library allows us to handle a whole range of things that that we don't really have to know about all that much. Computer languages use functions for lots of operations, you know, taking the sign of something, doing you know, the square root and so on. And what we do in the function library is we create a mapping between a function in one of our source languages and SDTL. And then we store these things in an external file. It's not part of the language definition per se, but it's available for anybody who wants to use it. And it expands the number of things that can be done. So from our point of view, all functions have the same format, which is that they have an SDTL name and a set of parameters. As you saw earlier, SDTL uses functions for arithmetic. It also uses functions for logical conditions. So this greater than operator gets turned into a function in SDTL. And functions can be computed across a row using multiple variables on a single row, or they can be computed on a whole column in a data frame. So what the function library does is it gives an SDTL version of a function that has parameters, which we, for simplicity, we just call it EXP1, 2, 3, and so on. And then it shows you how the corresponding function in SPSS, Stata, SAS, R, and Python looks, and where those, you know, SDTL parameters come from in that source language, which allows a computer programmer who writes the program that translates SPSS or R into SDTL to know how to do things, and it simplifies the writing of these parsing programs. So function library is going to be this file that's a mapping file that is part of what SDTL is. Now the pseudocode library is also a mapping file of a different kind. The pseudocode library is a way of mapping SDTL into natural language. And what it consists of are templates where you fill in the blank. So this is an example of a template for a command, and it has a little bit of text at the beginning. Then you put in a property of the command, then some more text, and another property and some more text. And I don't know if any of you have kids. I don't know if kids today still use them, but when our daughter was young, she loved doing something called Mad Libs, where you would, you know, where you'd have a text and these blanks, and you tell people to give you a noun and a verb, and then they'd be plugged in, and funny things would happen. Well, that's what the way the pseudocode library works. And what happens is that every property in SDTL can be eventually evaluated into its text string. And here's an example of how it works. So here's a very simple compute statement that just says age in years equal to 12. And this is the natural language pseudocode version that we would get from that. So how do we get there? So first of all, we've got a template for a variable symbol expression. And the variable symbol expression just simply says, you know, put in the variable name, which is here, and that's age years. And we have a similar template for a numeric constant expression, which only doesn't have any surrounding text, it just has a value. And then we have a template for a whole compute statement, which has the surrounding text of set and to, but here we put in the variable which comes from here and the expression which comes from there, which now we have evaluated. So now we know that the variable is age years and the result, the expression is 12. We put them into these boxes and we get this. So it's a tedious but straightforward process to go from SDTL to natural language. And what the pseudocode library is a schema for setting up these templates. And we have a pseudocode library that we made for the C2 metadata project, but you could do others. You could have a pseudocode library, a schema for French or German just as easily, and it would work in the same way. So now let me tell you a little bit about limitations of SDTL. First of all, there are a number of limitations of the software that I talked about from the C2 metadata project. First of all, it's only designed to work with metadata. It doesn't actually read the data file, which poses some limitations. When it comes to R and Python, we focused on one library in each because they have thousands and we can't do everything. There is limited support now for macros, and I think no support for user-defined functions yet. But these are limitations of the software, and they're not limitations of the SDTL language. These are things that are just about the strategy we took because we had limited resources and time. The big limitation, I would say, in SDTL right now is that we don't describe analysis commands. On one part of that, I think is fine because what the results of your regression equation that go into your paper are not a concern for us. However, if you use those regression models to create predicted values and residuals, then you've created new data, and that we haven't done yet. That's something that we're talking about doing, about creating a way to capture the information you would want to need to describe something like a predicted value that comes out of a regression equation. That's more complicated than the things we've done so far in C2 metadata. So we're still figuring out how to do that, but that's something that remains to be done. So now about how SDTL will work in the DDI Alliance. So the DDI Alliance has set up an SDTL working group. I'm the chair. We've already been meeting for several months. And the SDTL working group will be responsible for the SDTL standard. And we're planning to make it, we've already started the transition from the C2 metadata project, which created SDTL, to the SDTL working group, which is part of the DDI Alliance. The C2 metadata project has an end date. It ends next September, and after that, SDTL will be, we hope with your support, will be managed by the DDI Alliance. And SDTL will be managed as a standard using the rules that the DDI Alliance uses for managing standards that control how things are updated and how new releases are done, so that people who use the standard have a voice in proposing changes, and also have plenty of advance warning when something is changed, so that everybody stays in sync. So finally, we have these slides will be available, and they have a number of links to various things on them. I'm not going to show them now because I want to leave time for questions, but you'll be able to get back here. And I'm going to stop there. So I haven't been watching the
Thanks very much, George.
yeah.
So now's the time. If you have questions, please either put your question into the chat box or unmute yourself and ask your question.
Gee, no questions. Maybe the sound was off. Well, if people aren't going to ask questions, let me show you some things. Okay, so this link goes to the user guide for SDTL, which is on GitNet. We're maintaining on GitLab, and you can find all sorts of things in here about use cases and descriptions of the language, as well as a link to the actual details of the language. There are a couple of articles here about the project and SDTL, but I also want to highlight this page, which has been produced by our friends at MTNA, in particular Carson Hunter, who's on the call. And there are actually two data transformation recorders here. The one that I showed you is this one, which is an open source version that we made here at ICPSR, but Carson and her colleagues have made a much nicer version that has other features that you can try. As of today, there are still a couple of bugs in the Codebook generator, but you're welcome to try things. Things are still incomplete, so things aren't going to be working, and if you try something and it doesn't work, send us a note. But the other thing that's very nice that Carson has done here is all of those little program components that I showed you on a slide are actually managed as APIs. And so, this is the SPSS to SDTL parser, and here's the Stata parser and the R parser and so on. And this page has a pointer to the GitLab repository that where you can get the code, but also this is documentation about the APIs. If you're a programmer and you want to try out the APIs, that information is here along with the Postman. So this is a really nice page for finding if you actually want to try the stuff.
Hey, George, we got a couple comments, one question. So Anne said, great info, thanks. And Marika said, thank you for your presentation. If I have my script split up into several, for example, in Stata by doScript, is it possible to transform these scripts all together?
So at the moment, no. I mean, one could make a, as I said, our recorders is the web page that links all of the various pieces together, and currently it only works on one script at a time. However, it's very fast, so if you have, 3 do files, you could just, feed them in one at a time and they'd be linked. On the other hand, it's certainly possible for someone to write a recorder that's set up to handle multiple do files. And the open source recorder is actually written in Python. You could just, if you know Python, you could have a program that knows Python. So for right now, if your workflow is that you've got 3 or 4 do files and you run them sequentially, you would just run them through the data transformation recorder sequentially, and each time putting in the next DDI file. But I should also mention that the recorders can handle multiple input files. So if your script does a merge, or if your script actually reads one file and then does something to it and then merges it with another file, we can handle that too.
Great. Another question from Ryan says SDMX, the statistical data metadata exchange, has some level of interoperability with DDI. SDMX has a validation and transformation language, VTL. Is SDTL interoperable with VTL, or is it related to VTL?
So that's an interesting question, because we've been watching VTL from the beginning of our project, and the short answer is that from the point of view of SDTL, VTL is another source language. That is to say, one could have a parser that would read VTL and translate it into SDTL. The two languages have different emphases. VTL actually, the V is very important to VTL folks, the validation part. And VTL has a number of validation areas that SDTL doesn't go into. But VTL also does not have if you need a way to translate it into another language into VTL, we've actually proposed to the VTL folks that ultimately SDTL could be used for that, because if you, as I said, if you're doing translations, if we had an SDTL to VTL translator, you would automatically have a way to go from SPSS, Stata, SAS, R, and Python into VTL. So this is something that I hope will be worked on in the future. We had, a very nice conversation with the VTL folks, and I think that we each understand, the different places that we're filling in the overall metadata world. Okay, so there's a question here from John Johnson. Presumably, if you just wanted to document a script but haven't got the data file or metadata, SDTL would turn it into something that was more readable, especially if you didn't know the specific language. Yeah, you could. Well, I think you could do more than that. So, most of our use cases involve starting with a DDI file, but you can take a script and just create SDTL from it using one of our APIs. And then once you've got that, you could do a number of other things with it. So, for example, we have a project with another NSF project called Wholetail, where they're interested in using SDTL for data provenance, and they're working on translating SDTL into Prov1 RDF which could then be queried. So you could write queries on it to learn about what's going on in your script. So again, this depends on what software is written for it, and what people would like to do with it.
Great. So we have about 5 more minutes. Thanks to everyone who submitted questions. Okay, Christophe said, thank you for your presentation. A lot of information. How to deal with functions that are not in the SDTL library? Is it possible to document specified functions?
So the answer is that the SDTL library is designed to be, expandable. And now we have to have a bit of a gatekeeping function process to make sure that it's working. But any function that can work in one of our source languages can be put into the SDTL function library. In fact, that's what I've been working on for the last week. I've been going through functions and updating them and adding, working on adding new functions. It's sometimes complicated, and what I've been doing actually is especially in R and Python, which are languages I don't know very well, I'm actually running the functions to make sure I know what they do. But if you have a function, you can add it. And we've got, I don't know, right now, somewhere on the order of 150 functions in there. That is to say, 150, some of those functions are in all 5 languages, like sine and cosine, and some functions are only in a specific language. I'm planning to, hopefully soon, add in all of the functions for statistical distributions, like the normal and the binomial and so on. Those are pretty standard across all 5 languages. And so I'm going to sort of add them in a block, but that'll add, probably another 150 functions. But the point is that, if you can describe it. Now, what we don't support yet are user-defined functions. That is, when you write a function inside your script and reuse it. And we're discussing how we can support that. So here's something from Wendy. My assumption is that there would be a means of filing issues to request additional functions to be added to the library. Is this correct? Yes. Yes, Wendy. And you and I should talk about whether we want to create a separate issue track for functions. But yes, I'm not going to show it now, but there is an on the references, there's a pointer to the SDTL working group page, and people can create issues on that page for the group to consider. And John writes, the DDI Alliance, when it is accepted as a standard, will act as a community resource to decide which new functions are added as part of the core library. Yeah, so exactly. So we see functions, adding functions because they are part of the language will be something that we would like the community to participate in.
All right, well, we only have a couple more minutes, and it looks like the questions, we reached the end of the questions. We want to thank George for giving this presentation, and just remind people that the DDI community will be voting on whether to include SDTL in the product line of the DDI Alliance. The voting period will open tomorrow and run for 2 weeks. Questions can go to George about SDTL and the presentation here. There's also a page for the SDTL working group that is on the DDI Alliance wiki. I'll paste that here, and I'll also paste the George's email address. We will be posting this presentation online, so you can reference it. And thanks again to everyone for participating in this webinar. George, did you have anything else to say?
No, just thanks to everybody for turning out, and please vote. I'm not talking about the vote tomorrow in the US. I'm talking about please vote for the SDTL adoption process.
Okay, thanks, George. Bye, everyone. Thanks for attending.